Don't forget to subscribe and ring that bell.
I feel good today. I feel super today. I don't know if it's the extra shot of espresso or maybe it's because we're about to do some calculus. The 2023 AP Calc AB exam, free response question numero 4, and we don't get a calculator. Are you mad? We don't get a calculator. Are you mad? You're crazy. No, it's okay because the math, when we don't get a calculator, is very doable as long as you're good with your algebra. Brush up on those algebra skills and plug your nose because we's about to jump in. Let's start free response question number 4. Number 4 reads, well, first of all, before I read this, have I told you, if you've watched any other of my videos before, how much I love charts, tables, and graphs? Oh, man, I love when we get those as aids like we do for number 4 here. Anyways, number 4 reads, the function f is defined on the closed interval from -2 to 8 inclusive and satisfies f of 2 equals 1. The graph of f prime, the derivative of f, consists of 2 line segments and a semicircle as shown in the figure above. All right, great, fantastic. Does f have a relative minimum, a relative maximum, or neither at x equals 6? Give a reason for your answer. Okay, first thing we need to process. You know what word I haven't used in a while? Synthesize. The first thing our brains need to synthesize. I don't even know if I'm using that word in the right manner because I ain't no English teacher. But what you do need to know is the following. Oh, we already got purple. Fantastic. If I'm looking for a minimum or a maximum, okay, that means I'm looking at the first derivative, okay, the first derivative of x. Okay, I see where it's equal to 0. And then around that 0, again, in reference to the first derivative, if I have a negative to positive first derivative, that means I have a negative slope to a positive slope. That would give me a minimum. If I have a positive first derivative and then go to a negative first derivative, derivative means slope. That means I have a positive slope to a negative, and that would give me a max point. Okay? If I don't have either of these situations, that means I have neither at x equals 6. The graph we have above is the graph of the derivative, right? Do not look at this graph and say, oh, it's the graph of f. Let me look at the slope of this graph. No, this is the graph of the derivative. So even though it says the graph of f prime right here, I put up top where it says y equals the first derivative of x. That means whatever my y value is for any points, that's also the value of my first derivative or slope of f. Why is that important? Well, anytime I'm above the x-axis, I have a positive y value. And what does that mean? That means anytime I'm above the x-axis, not only do I have a positive y, but I have a positive first derivative. So here in the graph, positive first derivative. Here, 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 okay? Anytime I'm below the x-axis, I have a negative first derivative. So now on the graph, negative, negative, that's it. And anytime I touch the x-axis, it's 0. That's a critical point at these points right here. All right? So let's look at our graph, and let's figure out specifically at x equals 6, because that's what they give us. So at x equals 6, again, right here, this point, on this line, all right? That's where my first derivative is equal to 0, so that's a critical point. What does the first derivative do before and after that critical point? Well, I have a positive y value, so I have a positive first derivative. It hits my 0, but then it stays positive. So if I had to graph something that looked like that. Remember, what they give us here is the first derivative. So if I want to graph the original function, just f of x, where x equals 6, okay, it's going to be positive. Then right where x equals 6, it's going to kind of level off and be 0. But then it's going to go up again. Positive slope to 0 to positive slope. That is neither a min or max. Okay, that is not a min nor a max. So that's our answer. It's neither. Give your reason. Well, we're going to just kind of write a brief little statement about what we just discussed. So the answer is neither. Since f prime of x does not change sign at x equals 6. That's it. It was positive, it stayed positive. That's not a min nor a max. And without all this explaining, that should take you about all of, I don't know, 8 seconds to realize, and then another maybe 5 seconds to write. We could do that in 13 seconds, kids. You and I. Let's go. 4b asks, on what open intervals, if any, is the graph of f concave down? Give a reason for your answer. Again, let's process some things here. All right? We have the graph of the first derivative. So y equals the first derivative of x. That's what we have. If we look down here on 4b, it's where we're concave down. That means my second derivative, that's concavity, has to be less than 0. Okay, it has to be negative. All right, so that just means negative. I just write the inequality signs because it's less writing. But since you're here and you need help with this problem, or you're just checking your answer, that's fine. I'm going to write a little bit more. Okay, so let's figure out where the second derivative is negative. We have the graph of the first derivative. Oh, kids. One of the basic ideas behind calculus, AB, is you have an original function, you have a derivative, you have a second derivative, okay? Our graph right now is the graph of the first derivative. These are always one derivative away. The derivative of f gives you f prime. The derivative of f prime gives you the second derivative, f double prime, if you want to say. So this is what we have. This is what we need. Okay, so let's disregard this for right now for this question. We're one derivative. Derivative is the same thing as slope. So if I'm at f, I just look at the slope, or excuse me, if I'm at f prime, I just look at the slope of f prime, and that will give me the second derivative. So let's take that mentality down here to our little note. The second derivative needs to be negative. That means the slope of the first derivative needs to be negative. Okay, because the second derivative is the slope of the first derivative. Now, when we know that, this becomes significantly easy. Okay, all I'm doing is I'm looking at the slope of this first derivative. Okay, this is a negative slope from here to here because it's going down. This is a positive slope from here to here because it's going up. This is a negative slope from here to about here. This is a positive slope from here to there. Let's not forget slope of 0. Okay, this is a corner. That slope is undefined, and this slope is undefined. Okay. What are we looking for again? We are looking for any place that the slope is negative. Here. Looks like to me, from where x is, yep, that's the wrong thing, kids. When x is -2 to when x is 0, okay, this interval from -2 to 0 on the x-axis, has a red mark. And then from when x is 4 to when x is 6. That's all I got to write. And then give a reason. Again, we'll put a little statement. So I'm going to say from -2 to 0 and from 4 to 6. And give a reason. I don't know. I mean, that's where the slope of the first derivative is negative in those intervals. I mean, that's it. It's literally what we thought of how to solve the problem. So let's write it down. These intervals are where the slope of f prime of x are less than 0 or are negative. And if you want to be specific and say, therefore, the second derivative is negative. But that's it. If you write this, you're telling them you know this. We're done. I mean, A and B were layups, kids. If I told you how much I like cake, chocolate cake with chocolate frosting, man, I'm a chocolate freak. A and B were cake. All right, 4C, and it looks like we finally get to do some algebra here. Do some like math and calculations with numbers. This is good. Find the value of 6 times the f of x minus 3x all over x squared minus 5x plus 6 of the limit as x goes to 2. Or show that it does not exist. Justify your answer. All right, well, first off, let's the easiest way to do this is to just plug in this 2. So what I'm going to do is I'm going to take this value, where x equals 2, and I'm going to plug it in for every x here. And let's see what we end up with. All right? So I have, well, let's go gray. I'm in a grayish mood. Let's go gray. All right? We got 6 times f of 2 minus 3 times 2 all over 2 squared minus 5 times 2 plus 6. All right? So the bottom, this 2 squared is 4, minus 5 times 2 is 10, plus 6. Okay? All right, the top, the right side of the minus sign is 6. F of 2 is the issue. It's 6 times whatever f of 2 is. I have the graph of the first derivative. Don't look at 2 in this point and say, okay, that's the point 2, 0. So when f of 2 must be 0, so I should put a 0 down here and replace this. No, f prime of 2 is 0. This is the graph of f prime, not f. How do we get that? What do I got to integrate something? Wow, that thing just ran. And he ran. And look at now, it's not erasing. We'll pretend it's not there, children. Gotta love technology. Anyways, if we read our initial information in here that I'm boxing in red, f of 2 is 1. So wherever I see f of 2, I can replace it with a 1. Oh, that's nice. Which means this right here is really 6 times 1. Okay, that's 1. 6 times 1. 6 times 1. Okay, well, 6 times 1 is 6. On the top, we got 6 minus 6, which is 0. 4 and 6 is 10 minus 10. Okay, I end up with 0 over 0. Man, that's still bothering me. Look at that. Look at, you see that, kids? I can't erase it. I don't know. I kind of like it there. Anyways, back to the problem. Okay, we got 0 over 0. My God, this is hard to pronounce, but easy to do. All right? Anytime you try to take a limit of something, like we did right here, and you end up with 0 over 0, you can apply something called L'Hopital's rule. I don't think there's an E at the end here. Again, I said I'm not good at English. And if there is not an E there, and you're like, well, you spelled that right. Well, I don't know. Maybe I can spell math words right. Maybe that's not right. I don't care. I just care how to do it. All right? L'Hopital's rule. What L'Hopital's rule says is, if I end up with 0 over 0, like I did right here, I can take my original, just take the original function. I could take the derivative of the numerator and the derivative of the denominator separately. I do not do the quotient rule. I take the derivative of the top, I take the derivative of the bottom, and then I try plugging in my 2 one more time. And if I end up with 0 over 0 again, guess what? I do it again. Derivative of the top over derivative of the bottom. And I keep on going until I don't end up with 0 over 0. So let's take the derivative, and we'll go to purple again. Let's take the derivative of just the top, and that will become the new numerator. 6 times f of x becomes 6, that's a constant, times, I don't know why I said thicken, that's why. There you go. That erased. 6, and the derivative of f of x is just f prime of x, minus the derivative of 3x is just 3. That's the derivative of the top, so that's the new top, or new numerator. Derivative of the bottom, x squared becomes 2x, minus the derivative of 5x becomes 5, and the derivative of 6, well, that just goes bye-bye, turns into 0. Now that I've taken the derivative of the top and the bottom, I again try and plug in an x value for 2. If I get 0 over 0 again, well, then I take the derivative of the top and bottom again and try and plug in 2 again. I just keep on going, all right? So let's start here. 6 times f prime of 2 minus 3 all over 2 times 2 minus 5. All right, well, the bottom isn't going to be 0. This is 4. 4 minus 5 is negative 1. All right? And the top. Now we need f prime of 2. Now I can go look at my graph. This is legit now. Because we said this thing that moved away that, you know what would be embarrassing, I just thought? I see f of 2 right there in red. If you don't see it, and I'm just talking about this thing that's not there, it's crazy because it's there on my end. Anyways, f prime of 2 is 0. That's an x and y coordinate of the graph of the derivative. So anywhere I see f prime of 2, I'm going to substitute in a 0. So I come down here. This becomes 0. 6 times 0 is 0. 0 minus 3 is negative 3. Negative 3 over negative 1 is positive 3. We're done. Let's move on to the final part because, you know what? I'm liking this. The final part of question 4, 4D, states, find the absolute minimum value of f on the closed interval from negative 2 to 8 and justify your answer. Justification is math work. We don't need to write words unless we can come up with it analytically without doing algebra and math. In this case, we absolutely can do it using math, and we should. So here we go. Minimum. First of all, let's determine where the minimums could occur, all right? And then we need to find the minimum value, which means we need to find the y value. They don't want to know where the absolute minimum occurs. They want to know what the absolute minimum value is. If that confuses you, okay, a minimum value happens at a point, an x and a y coordinate. This is where it occurs, the location. This is the actual value of the minimum right here. So if I find out that my minimum happens at x equals 11, for example, if the minimum happened to be here, this has nothing to do with the graph to the left. I'm just giving you an example. The answer isn't 11 as the min value. That's where the minimum happens. The actual min value would be negative 2. So because they're asking us for the minimum value, I want the y value. Kids, I tell you, life is funny. Anyways, I want the min value, I want the y value of the minimum coordinate. Now, absolute means the lowest of low. There's only one of them. Let's start by finding out where all possible minimum values can happen. If I want a minimum value, okay, if I want a min value, that means I want to find out where my first derivative is either 0 or undefined. Okay, and then I want a negative first derivative to a positive. Okay, we have the graph of the first derivative. Okay, the first derivative is 0 at this point, and at this point, and at this point. Now, if you were with me for 4a, we determined that at this point, it is neither a min or a max. So this one, we can just take right out of the picture. Okay? So it's either -1 or 2, and we're not done. So don't say, oh, you missed something. Not done. Let's figure out where my first derivative goes from a negative to positive. Again, for 4a, we determined that the y value is the same thing as the derivative. So these are positive y values for all these points. So it's a positive first derivative. All these points are below the x-axis, so they're a negative y value. So I have a negative first derivative. And then all these points that make up these lines and curves here are all above the x-axis, so they're all positive. So when it comes to my critical points, here and here, as I go left to right, okay, this one goes positive to negative. I don't want that. I want negative to positive. This one goes negative to positive. Okay, right here is a minimum. Okay, that's a minimum value. Now, before we just say x is 2, let's figure out what it is. Oh, look at f of 2 is 1. Okay, so that my coordinate is 2, 1. Here's x, here's y. This is where it happens. This is the where. And this is the actual value, the min value. So it would be 1. We have endpoints. We need to check our endpoints to make absolutely sure, okay, that neither of our endpoints are lower than 1 on the y-axis for the original graph. So this is what I'm going to do. This is what I'm going to do because I like you guys. Here's x. Here's f of x. Our two endpoints are at -2 and 8. And we know 2 is a min value based on our graph. And what's given to us is the coordinate 2, 1. So right now we're going to check, is there anything lower than this? Is this going to be lower? Is this y value going to be lower? I don't know. That's what we got to figure out right now. Okay? So here we go. Ready? First of all, how do I figure out what -2? All right. How do I figure out the y value at -2? And I can use integration to figure out displacement, like how far I'm moving, okay, on the y-axis. What do I mean? Okay, let's clean this out, and hopefully none of this slides. Clean this out, get rid of this right here, and this right here. Why not? All right, so we know for a fact that right here, okay, when x is 2, okay, when x is 2, my y value is 1. So let's figure out, okay, this is the original function. So this is like f of x. What's the displacement from 2? I'm at 1. So how far from 1 am I moving? All right, well, displacement is an integration. Integration is area under the curve. Okay, it tells us we have 2 line segments in a semicircle. So, okay, starting from here, I have one triangle, and I have another triangle right here. Okay, this triangle is 2 by 1, so it's 1/2. The area of a triangle is 1/2 base times height. Half 2 is, so this is 1 right here. And this triangle is a width of 3 and a height of 2. So it's 1/2 times 3 times 2, which is 3. Okay, so if I have, all right, if I start at 1, and I'm going backward, right? I'm subtracting, because this is moving backward, isn't it? It is. I subtract the areas under the curve, which is the integral. Okay, this integral is telling me the movement. All right? We have a positive 1 because it's above the x-axis, and that 3 is negative. All right? Remember, if I integrate something from -2 to +2, that's the area under the curve. That's what we just did. Okay? Let me say that one more time, because from -2 to +2, we're doing this area under the curve right here. That's my integration. I'm not doing absolute value. That means anything below the x-axis should be negative, okay, of f prime of x dx. That gives us the difference. It gives us the difference of the original function from the upper bound minus the original function of the lower bound. Okay, that's that difference in movement, all right? Because it's area under the curve, and we don't have absolute value bars here, okay? Not everything is positive. It is not total distance, it is displacement. The 1 is positive, the 3 is negative. It's -2. I've got to subtract that movement -2. 1 minus a -2 is 3, and there you go. So the y value at -2 is 3. This is not bigger. This is still smaller. That's still an absolute minimum. It's still lower on the y-axis, okay? Let's put that 3 there without the box. Okay, this is still the champ. What about at 8? All right, well, I could do a thing. I'm going to do 1, but this time, since I'm moving forward, I'm going to add the integration from 2 to 8. So all that area under the curve. You don't even have to do this. Do you want to know why? Well, there's 2 reasons why you don't have to do this. The first thing is, if I go from 2 to 8 this time, the area under the curve from 2 to 8, let's get rid of all of this right here. From 2 to 8. Isn't this all, this area under the curve, isn't it all above the x-axis? This will be a positive value. That's not a negative value. Positive area here, positive area here. Don't sit there and try and do triangles and subtract this. That's crazy, okay? So if I have 1 plus some positive value, that will be bigger than 1. If I add anything to 1 that's positive, it will be bigger than 1. Okay. So I know if it's bigger than 1, this is the minimum. Or if you're a smarty pants, you can say, well, if 8 is my right endpoint, okay, and I think the minimum is at 2. Here's my minimum at 2, 1. Okay, right here. That's the minimum of f of x. And here's 8. This is my first derivative, isn't it? That's slope. Isn't the slope constantly positive till it gets to 8? So I don't know what it's going to do, but it's got to go up at some point to get to 8. We have a positive derivative going to a right endpoint. That means it's higher up. Okay? You can explain it that way if you need to. All right? But this is good enough. This right here is justification. All right? And the minimum value is 1. It's not 2. 2 is where it occurs. And this is the absolute minimum value. Whew. It's the concept behind it that I have to explain that makes this longer than the actual math. Okay? It's the concept behind it. Guys, I had a blast today. I'm going to have a great rest of the day because I haven't taught my calculus class yet. I like teaching them. Okay? And well, I like teaching everybody. What the hell? I just like math. All right. I'll see you for Free Response Question 5 coming soon to your YouTube link, browser, your YouTube site, my channel. However you watch it, I don't care. However you say it, I don't care. Just watch it. I'll see you.
Don't forget to subscribe and ring that bell.